Hey there, welcome back. Well, before the break, I asked you which of the following are vector quantities? Number 1, density. Number 2, mass. Number 3, force. And number 4, velocity. The correct answer, of course, is number 3 and number 4, that is force and velocity. Both these quantities require magnitude as well as direction for their complete representation. So let's tweak it up a notch and get cracking. Gravity. Let's start with the mother of all forces, gravity or gravitational forces. Gravitational force is the force exerted by any body of a certain mass on all other objects with a finite mass. Gravitational force is always attractive in nature. It is a non-contact force between the earth and all objects near it. It always acts towards the center of the body exerting it. So in the case of Earth's gravity, it is always directed towards the center of the earth. We feel our weight because of Earth's gravity. The moon revolves around our earth because of the gravitational force between the earth and the moon. And do you know why the sea tides are caused? Due to gravitational force of moon on earth. This is the most spectacular display of gravitational force in action in nature. Now, let's crack the concept of normal reaction. So, normal reaction is a contact force which is exerted by the surface on which the body is pressing against. Say, for example, this book. Now, this book is resting on the table and it presses against the table surface. The table exerts a force on the book which is normal to the surface of the table. This presses down, the table presses upwards. This force is known as normal reaction force of the table. Frictional forces. It is the force exerted by a surface as an object moves on it or shows a tendency to move on it. Remember, friction opposes the motion of an object with respect to the surface on which it rests. To demonstrate, here's another high-tech piece of equipment I'm going to use. A heavy coin. See how the top of this table opposes my pushing this coin. And that is why when I stop applying the force, the coin comes to a standstill after a while. Watch this. It stops. Why did it stop? I pushed it, but it stops. That is because the surface of this table exerts a frictional force on the coin and makes it stop. So we have learned that often friction opposes the motion of an object with respect to the surface on which it tries to move. Right? Now, here's another question by one of our viewers.
Charlene, what should I do to move a block which is at rest? Should I pull it with the force which is less than the friction, or should I pull it with the force which just exceeds the friction, or should I pull it with the force which is equal to the friction?
That's a good one, and I guess your examiner may ask you the same. So pay attention. Basically what you want to know is how much force to apply on the wood block to make it move. The correct answer is that if we pull the block harder and harder, the tendency of the block to move increases, which increases the frictional force, until we reach a point where it hits the maximum value. And if we pull harder still, the block will begin to move the moment the applied pull just exceeds the friction. Now, here's a paradox. If an object is not in motion, does it mean that there is no force acting on it? Well, what do you think? If you thought that just because an object is stationary, no forces are acting on it, you couldn't be more wrong. Don't believe me? By the way, you already knew the answer to this one. Remember the tug-of-war match? Before I joined in, the two teams were hard at it, but neither of the two teams were moving. They were both pulling both ways, but nobody was moving. Do you know why? It was because the sum of all the forces acting on the system of the two teams, the rope and the ground, was 0. In other words, the forces balanced each other, and this is known as a balanced force system. So the definition of balanced force is if the resultant of all the forces acting upon a body is 0, the forces are called to be balanced forces. Any number of balanced forces can act on a stationary body, but as long as the resultant force is 0, the body continues to remain stationary. For a body at rest, the pull is balanced by the friction in action. However, since the forces are balanced still, the body has not begun to move. Similarly, if a number of balanced forces act on a moving body, the body continues to remain in a state of uniform motion. For a body in constant speed motion, the applied force is balanced by the constant friction in motion. This is again balanced forces in action. Now then, having spoken about balanced forces, it is only fair that we talk about unbalanced forces. Forces that do not sum up to 0 constitute unbalanced forces. Look at this example again. Let me drop a ball. There are two forces in action here. The weight of the ball acting downwards and also the air resistance acting upwards. Since the ball falls downwards and appears to be gaining motion as it falls, it implies that the weight exceeds the air resistance. I mean, we know that, but the point is there are two forces and one of them is much stronger than the other. So it is unbalanced forces and the ball does move. The ball is under the action of unbalanced forces. Thus, if the resultant of all the forces acting on a body is not 0, the forces are called unbalanced forces. When unbalanced forces act upon a body at rest, it begins to move, like it is at rest, and it begins to move in the direction of the unbalanced force. Like in the falling ball, the ball falls in the direction of higher force, that is weight. To go back to our tug of war, when I joined one team, the force that was till then balanced became unbalanced. Each team in the game of tug of war uses force to try to pull the other side towards itself. If both the teams push the ground equally hard, the forces on the combined body towards the right is equal to the forces on the combined body towards the left. In this instance, the forces are balanced, that is, equal and opposite, and in the effect cancel each other out. But when I joined one team, my team pushes the ground harder than the other team. The force exerted by my team is greater than the force exerted by the opposite team. Here the forces are not balanced, they are unbalanced forces. The entire system, the team and the rope, experienced an unbalanced force and the black team won. Well, it's time for a break now, and we come back, we will find ways to sail through our exam and score those marks with Exam Decoded. In the meanwhile, keep watching.